Alright, so I'm just going to do a couple of examples where I move from rectangular into polar form and I give my answer in radians. Alright, so I'm going to pick two of the questions you're doing for homework. So first up, question 2, which is just 2 root 3 plus 2i into polar form. Alright, so argon diagram, that's where it would be. So I need to get the modulus and I need to get that angle. Alright, so first up, get the modulus, which in this case we call OR. So OR is equal to square root a squared plus b squared. So it's the square root of, it will be 2 root 3 squared plus 2 squared. So a and b. You can just plug that into the calculator now. So square root 2 times root 3 to be squared plus 2 squared is 4. Alright, other thing we need is this angle. So I have a right angle triangle where this side here is 2 root 3 units and this side here is 2 units. Okay, so tan is opposite over adjacent. So if you get the tan inverse of opposite over adjacent 2 over 2 root 3, you'll get that angle. Okay, that's 1 over root 3 as well, but you don't need to notice that to get this right. So second function, tan inverse of 2 over 2 times root 3, that is equal to 30 degrees. So in polar form, our complex number is or cis, the angle, so it will be 4 cis 30. Okay, we're going to give it in radians. Alright, so there is a few different ways you can do it. You can just remember how to convert between degrees and radians. To go from degrees into radians, you multiply by pi over 180. Okay, it's multiplied by 180 over pi to go the other way. So if you do 30 multiplied by pi over 180, you are going to get 1/6 pi, or pi over 6 radians. Okay, so the complex number is 4 cis pi over 6. Alright, other ways we could do it. So calculator will convert between degrees and radians for you. So 30 second function, the decimal there, and you should see that it's 1 over 6 pi, so the calculator will give you the same answer, pi over 6. Alternatively, we could just do the question in radians. So my calculator is set to radians mode now because I did that, but set up 0 for DRG and then pick 1 for radians. I'm in radians mode now, so now if I did second function tan inverse of 2 over 2 root 3, I would get 1 over 6 pi radians as well. Okay, so you can do it using degrees as before and then just convert the angle using multiplying by pi over 180. You can get the 30 degrees, convert it on the calculator, or you can just have your calculator in radians mode, and then when you do the tan inverse, it will give you your answer in radians mode. However you do it, z is equal to or cis, the angle, so 4 times cis pi over 6. And remember, cis just means the cos of the angle plus I sine times the angle. And that's that one done. Alright, if we do question 11 then as well. So minus 4 root 2 minus 4 root 2i. So my argon diagram, minus and minus are going to be down here. So I'm going to get the modulus. I'm going to figure out how big this angle is, and then I need to do a little bit of work here because it's going to be a negative angle. Now, I'll worry about that in a second. So get my modulus first. So or is equal to the square root of a squared plus b squared. So or is equal to the square root of minus 4 root 2 squared plus minus 4 root 2 squared. Plug that into the calculator. Square root of minus 4 times root 2 2b squared plus minus 4 times root 2 2b squared, and that is equal to 8. So my modulus here is 8. Now to figure out this angle, which again is called, or well, this one here is called the modulus of my complex number. Okay, so I've got a right angle triangle here where this side is 4 root 2 and this side is 4 root 2. So I'm going to get the tan inverse of 4 root 2 over 4 root 2. Which is just the tan inverse of 1. So I'll just do this from degrees mode and then we'll sort that later. So second function, tan inverse of 1 would be 45 degrees. So this angle here is 45 degrees. So I'm going to figure out this angle, which is just going to be 180, take away 45, which is 135 degrees. So in degrees mode, my complex number is or cis that angle. So 8 times the cis of minus 135. Okay, so when you're going down here, you're going to have a negative angle measured from here. All right, so to go into radians mode then, so just convert 135 into radians. So 135 multiplied by pi over 180. So 135 multiplied by pi over 180 is 3/4 pi. Okay, so 3 pi over 4. All right, so then my complex number will be 8 cis minus 3 pi over 4. I could also do that using the calculator, so just 135 second function d or g gives me 3 over 4 pi, so that's me getting it a different way. It would still be the same answer. Or you could go all the way back to here and do it in radians mode. So I'm in radians mode now. So second function tan inverse of 1 is 1 over 4 pi. So this would be 1 over 4 pi. Remember, 180 degrees is pi radians. So if you do pi, take away 1 over 4 pi, that's how I'd get that 3 pi over 4 or 3/4 pi. Okay. However way you do it, don't forget it will be negative. You are measuring from here. It will be negative angle. So in radians mode, in radians, my complex number is 8 cis minus 3 pi over 4.